Ba-dum, ba-dum. Can't do that because that's copyright music. Whoop, there we go. Do do do. Okay, so what are we doing here? File, new, PCB. One copper layer? Two. Okay, sure, whatever. This a little bit bigger. So for anybody that is going to end up joining in, yeah, trying to teach myself how to design a PCB. So wish me luck. Yeah, two non-printing. Well, this will be for printing. 13. Which one I use? I think this is one I used before. Yeah, that's not keyed. This one's keyed. Let's place. Should go right in the middle, and then we can always adjust it later. Thank you, Andre. Trying to learn this. So this is just gonna be I'm gonna call this right. Okay. So yeah, so this is easy EDA. Seems to be the easiest one I could find. I tried doing Fusion. I could not figure out how to do um, a lot in it. Um, and this seemed to be the best thing I could find for the parts that I need. Because now I can just do 4-pin JST. Like it actually has stuff that like comes up. So JST 4-pin header place. And I need 3 of these guys. Yeah, this is my first, well, this is my second time using this program. I was using it the other night. And yeah, it didn't work out so hot because I accidentally closed out the window and lost my progress. So now I can go this to be 2-pin JST. And really, the amount of these really doesn't matter. It's more of just, I just need the holes there to put the JST in. PH, that's what I want to place. And I need 4 of these guys. So 1, 2, 3, 4. Now, the one thing I don't really understand is routing the traces. The audio seems fuzzy. Just the front side of my mic, or am I talking to the back side of it? No, I'm talking to the front side of the mic. Vikings here. What's up, man? Um, well, so my thing is like, so I've got the trace tool, and I need to on these higher pins are all go to X2. So I make this X2, and then the next ones to that is X max. If I go, this one would be X max here. And then the next big 4-pin is going to be the E1. So I can go ahead and trace starting here. So this is, okay, so this is going to be 25. So 25 goes to X2M2. Icelandic interwebs. Hey, Brandon. So 25. So the thing is, like, so top layer, I think I'm just gonna go with, I mean, I guess what did I do last time? I think I did top solder mask layer. I don't really know which layer to do these on. Doesn't really make sense to me because I don't know PCBs. Like, is everything on the top layer okay, or do I need to like nest it down? I think top solder mask layer is what I want. But the thing is, if I stay with top layer, then I can actually like click and it will actually like kind of do what I want it to do, I think. Well, I only need this to be one layer. I mean, it's going to be holes so that I can solder on the components on top and then a trace to each one. Top layer and bottom layer are the copper layers. Well, I mean, I've got the holes on the top layer. Obviously, they go through. Or does that need to be multi-layer? Or does it really matter? All right, so we'll stick with top layer. So 25 goes to X2M2, which is 3. And then 26 goes to X2M1, which is pin 4, which that like crosses over. So that's one of the, so if I take this then, let's rotate this 180. Delete that. Now 25 I said goes to pin 3. 26 goes to pin 4. That's a bit better, maybe. So, okay, and then 23 goes to X2M4 pin 1. And this one goes to pin like that. All right, so there's that one done. Now the next two pins, so we've got 21 goes to run out 1, which is R1. So we'll call this one, we'll call this one R1 then. So pin 21 goes to the X max pin 1. So if I do like this, and then this, and then that, then this one goes to pin 1 of R1. Yeah. Like that. Okay. And then all the next ones, all the next 4 go here to E1. So So 19 goes to E1M2, which is pin 3. I'm going to flip this around as well. Same thing with this one here. I think it'll end up lining up better that way. So, what I say, 20 goes to E1M1. E1M1, where's that at? Port 4. Ooh, cranky. Can't do that one yet. Gotta do the bottom row here first. 19, E1M2, port 3. Yeah, that makes it tough to do that. So I guess that one will have to be, I'll just do it like this for now, but like it's gonna have to get moved. I guess, can I just switch to bottom layer and then do this to here? Like that and go back to top layer? Would that work? Because I mean, I don't know how much this will be to do a dual layer from JLC PCB, but it's going through the pin either way. It's not as good looking, but I don't know. And then port 17 goes to 1. 18 goes to 2. So like that. And back. So that should be okay, I think. And this one's going to be J1. Also, you may want to make the bigger connector centered between all the other connectors. Oh, you think going that way. If I move this, do those move? Oh, they move! Oh, cool. Okay. Yeah, let me connect all these and then... Oh, that's pretty cool. I didn't realize it could do that. Then I'm going to put all these on the top layer then, and then I can switch the layers later. So which was this one? This was 25, 23, 21, 19. This is 20. Where did 20 go? To pin 4. And then 18 went to pin 3. I see what you mean. Can I switch the layer? Oh, I can't switch. I can, okay, I can right click and switch layer. So we just need to get everything connected first. Okay, so let's switch the other side. So pin 1 is going to T negative, which is pin 1, J1. Pin 2 is the ground for anything. So I need a run out ground, X max ground. So we're going to do the run out ground. And pin 3 is T positive, so that's pin 2. Pin 4 is another ground for X max. Pin 5. Okay, so here's one of the interesting ones. So that goes to pin 3 of here, and there's 3 of them that go to that. So pin 5, 6, and 7 all go to here. And then this is where it gets a little bit tricky here too that I don't really understand. Create a schematic. I don't know how to create a schematic. Again, I've figured in creating a PCB, I mean, they have schematic here. So should let me save this first. So, oh, I need to create an account. Let me create an account real quick. That's why it doesn't save or do anything, because you're not logged in. My authenticator app going here. Of course. Let's see here. Not saved here. Can't find my password. Why is it not in here? It's not in my password manager. That's really cool. Not. Yeah, legit. It's not in my password manager. Definitely can't figure that out right now. Schematic, there it is. I just want this to be bigger. Oh my God. The order is imposed by the schematics. So should I switch to making a schematic, or should I don't know, schematic? I don't know how to do this either. Is this the same way? So if I go into here and I pull in, so I need 1, 2, 3, 4 of those. And then I need one, 2, 3 of those. Then I need a 2x13. I guess this is all I need right here. Doesn't matter if it's keyed or not. I just need, for DuPonts, place that here. Okay, so how then do I get rid of that? There we go. Get rid of that. Okay. Now, how do I set all these? R1 X max. fan 1, fan 2, J1, E1, and X2. This is just going to be called right. It's like now I do that, like yeah, I'm not worried with it, but how do I tell like what this is? Like, do I have to draw the wiring line? So pin 1 goes to J1 pin 1. Like that. Is that what I'm looking to do? Pin 2 is a ground. We'll give that to pin 2 of you. Nope. Pin 2 to pin 2. Wire to wire or use net ports. I see net label. I don't see net ground, net flag, net port. I don't get what that does. Connect them all. X marks. No, there's no X marks. There's just at the end of the pin. So like here's pin 3. So pin 3 is the positive for temp. So J1 pin 2. But now that like connects all of those, I don't want that. Yeah, everything's named the same. Pin 4 is another ground. So we're going to give that to X max pin 2. 5, 6, and 7 all go to J1 pin 3. So 1, 6 goes to there. 7 goes to there. Hey, Jerry, Merry Christmas, buddy. Keep on trucking. All right, keep on trucking. So, pin 8 is a 24 volt. So that's going to go to J1 pin 4. Pin 9 is another 24 volt. And see, it has pins 8, 9, 11, and 12 all together because they're all 24 volts. So I don't know if that matters. But 9 also goes to here. Just feel like this. Nope, don't do that. Whatever. We'll just keep going with it for now. Well, yeah. So I guess I'll have to figure out how to bridge those at some point. Um, anyways, pin 10. Oh no, I didn't do pin 8 yet. Pin 8 also goes to pin 3 there. Pin 10 is the fan 1 negative. Fan 1 negative, which is pin 1. And then 11 is a 24 volt positive. We can give that one to there. 12 is negative for fan 2. 13 is another 24 volt positive. We'll give that to fan 2. 13. I just did 13. 14 now is the Hall S negative 24. Yeah, for right now, I'm just trying to figure out just get the wiring up, and then I'll adjust what terminals I'm going to use on it. So I don't really have that figured out yet. Like these will all be JST, and the only one that won't be a JST is pin 1. There's a port 1, J1. What am I right now? I'm on 14. All S24 ground. It's not on here. It's because they're not used on this one. Because the Hall is on the left extruder, not the right extruder. So 14, 15, 16 are not used. So next one's going to be 17 to E1M4. So it's an E1 pin 1. 18 goes to E1M3 2. 19 to port 3. 20 to port 4. 21 is the X max there. 22 is the R1 run out. Okay. 23 is going to X2M4. So pin 1, 2, and 3, and 4. Okay. That's everything somewhat connected. So how do I take this from a schematic to a PCB? Convert schematic to PCB. Check nets. Sure, check nets. I don't know what any of that means. No, keep going. Please save your file. Let me try to make this account real quick. Sign up. Let's create an account real quick. Check my email. Verify my email address. Okay, so now I can log in. I'm not a robot. At least I don't think. There we go. Okay. Now I can save this. We're going to call this the Edu X40 rights. Save. Okay. So now we can go to design, convert schematic PCB. No, keep going. Because I don't know what that means. Sure. So that goes here. Nothing's connected properly. Yeah, that did not work out at all. Not at all. Because there's multiple connections because they connected to each other. So like all of these four are all connected to each other. So that didn't work at all. If I was to try to move it, it connects all in that way. That's not really working out too well. I feel like I might have been better off with this routing the way I was doing here. 1, 2, 3, 4, 5, 6, 7, and 8 also goes to here. 9's done. 10. Negative for fan 1. So unless I'm doing something wrong. Well, it doesn't really help me out. Like, this should not let them cross. So I'm just going to stick with this for now. And 11, we'll give that fan 1 volt. 12 is the fan 2 negative. 13 will be its power. We're not using 14, 15, 16. Okay, so now we move some of these. No, don't do that. You stay right there. I want the whole connector. Are the top four all the same, i.e. ground or 24? No, they're not. Well, it's a negative and a ground and a positive and a ground. I mean, to be honest, there really shouldn't need to be any changes made. That's not what I wanted. Oh my God, just get this stupid line out of here. Need more space. Let me see. Give it a minute. Okay. Still crossing over when they should not be. No, it can't be single row connector because the ribbon cable is 2 row. So I can't do that. This doesn't make sense either. Can I? So they move with me like this, which is cool and all. Is there a way to not draw lines? Because that's just super annoying. So I have that downloaded too. But I can't figure that out either. Because, like, so I started it. I think I started it. Let me see if it opens up. So, okay, so I had it here, but my problem is that I can't find like the connectors. It's what, this button here? I don't think that's not what I wanted. Is that what I wanted? Footprint editor? I don't think that's what I wanted there. Just get rid of all that. Stop. Everything go away. Go away. Discard. Oh no, the footprint editor. No, that's not what I want. I don't want that. So all right. So if we go back to, let's go back to easy one. Okay. So I'm gonna delete all these lines. Okay. So then if I do net label for pin 1 and a net label, where does that go? That goes over to here. So if we call this T negative, and this one T negative, like that, I'm curious. Don't say that. Okay, it does do that. Okay, okay. I'm tracking now. Let's do that. What part of a laptop the charging circuit is broken? I would check your connector. That's 9 times out of 10. Connectors are usually the thing that goes bad on a laptop first. Pin 2 goes to, we're going to call that R1. 2. This is ground, ground. So like that, is that how I should be doing this? So I want to like see it. So I guess like that. And then pin 3 goes to pin 2 here. Positive. D positive. Adam, I am working on, so I did a review, was it last week, on the WeDo X40. It's an IDEX machine, and um, it runs fine, but I want to make it run better. So I'm debating on either doing RepRap or Clipper on it, and I want to reuse the ribbon cables that are. Oh, hang on a second. It's still running. I want to reuse the ribbon cables that are on it. So I need to make my own breakout boards. Now I'm gonna buy boards from WeDo just in case this like goes down in a ball of flames. But I want to try. I want to challenge myself to learn to make a PCB, and um, JLC PCB said they would sponsor me, and this seems like an excellent time to learn and get some PCBs from them. So I'd like to. I want to actually try to give some away to the community. So this ground is going to go to the X max ground. Now, can I have multiple? Like, well, all these grounds are okay because they'll connect together. I'm guessing that shouldn't be a problem. So 5 going and 3 here. This is P1 dash 24 negative. P1 negative. That's also going to be pin 6 and pin 7. Pin 8 is P dash, well, pin 8's going to pin 4 over here. So that's P. We're just going to call this plus 24 volt. Like that. And then let's mark all the 24 volts real quick. So that's 8 and 9. And then 11 and 13. 11, 13. And then fan pin 2, pin 2. Oh, that's 24, not 28. Like that. Okay, and then what do we got next here? So 10 is fan 1 negative. Oh, didn't want that. So that's 50, they call that 50, 15, B negative. So 50, 15, B negative. Okay, get it out of here. Okay, and then 12 is fan 2s. Fan 2 is a 40-20 B negative. No. 20 V negative. 40, 20 V negative. Okay. And 14, 15, 16 are not used. So we're on 17 is E1M4. So pin 1. E1 dash M4. E1 dash M4. 18 is pin 2. So that's E1 M3. Well, yeah, this one I will not be, none of this is going to be soldered components. It's just going to be soldered connectors. So the PCB is just going to be a bunch of holes and traces. All these connectors are going to get soldered onto it. And then, yeah, that's it. Dash 3. 19 goes to here. 2. 20 goes to 4. So E1, M1. M1. Okay, we're getting there. We're almost done. Last 6 pins. So 21 is X max. So this is called 1 out 1. And that connects to, that's 21. Out 1. And this is x max. It's here to x max. Okay. We've got I'm just gonna hit all these like this. I'll label them all after this. 4. Okay. So pin 1 on this is x2 is x2m4 x2 3 x2 2 x2 m1. So 20 start from 26 x2 m1 x2 m2 x2 3 x2 oh that's m3 this one's m4 m4 okay so let's save this and I can do update PCB yeah okay so here it is got that there. Here comes the interesting part. Like, how in the world do you get this to like work? Like, there that is, but that I don't think that's gonna work out too well. Make it big so you guys can see it all there. Okay, that goes better if I spin that around. And then this one as well, if I spin it around. Goes good like that. Okay, so do I do that back in the schematic? How big I want the wires to be? And how do I do the auto stuff? So design, route, auto route, auto route. Okay, well, how do I say how thick I want certain wires, certain traces to be? Design tools. Yeah, but you tell me to figure out the how thick I want the things. I don't know how thick I want them. Let's just see what happens. Run. Install local router. Hang on, I need to install something. Design rules. So that. Design. Is it in here? Design rules? Oh, design rule. Okay, okay. So, oh my God, there's a lot to go with the auto router deal. So I don't know how much, what to change these to for the pad, the routes. I have no idea what that should be. Like what size is good or what not. Traces, I should say. How thick the traces should be. So that's Google. How thick should PCB traces be? Want that? Where did it? There it is. So is this mils? Because that might actually be pretty big compared to what I'm seeing here. I don't know. That doesn't make any sense. I mean, it's just a hot end. I mean, hot ends run what, 3 amps. So I'm looking at maybe 3 to 4 amps on the plus 24 volts. Everything else, whatever it is, it's just signal. And what's that? Usually like 3 or 5 volt. Is this millimeter in the units? Oh, down there. Ah, I see. I see. Okay. So if we add, we'll call this one plus 24 volts. Call that 1 mil, 0.2 clearance, 0.61, sure, 0.305. Not without taking the hot end apart, Aaron. I'm like, it's under the extruder. I don't think there's an easy way to get to it. Not without disassembling a fair bit. Might be something I can do later, but it's definitely not a tonight thing. It's now after midnight. I call that plus 24 volt. Apply. Keep that. Let me see where this. I gotta install this auto routing thing here. Trying to look at the tutorial on how to do it as well. Close that for now. Too many things open. This. So route, auto route, auto route, local available, run. Okay. So that's it. That's supposed to work. Oh, I see how those are going. Oh, and it did top and bottom. So I guess that's it, eh? PCB trace thickness calculator. Just want a digikey too. Cool. Cool, 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 cool. So I need it. It's gonna be 4 amps. Oh, it says it's supposed to be for 4 amps to be 3.6 millimeters thick. Width, I should say. Jeez Louise. That's internal. It's external layers 1.4 millimeter. So the current, I'm going to call that 4 amp. Where did I go that? So the route, auto route, design rule. Wait, 1.6 millimeter. Yeah, I don't understand. Because it's talking about temperatures. I don't really care. The temperatures really don't matter that much. I don't think. Like one of these says 3.6 millimeters, one says 0.1 millimeter. So being 2 layers, presumably yours would be external layers. Okay. But yeah, for external, it's saying 1.4 millimeter. So if we do 1.5, just to be safe, right? That'd be okay. What if we just make these 0.3 just because? Yeah, so make them a little bit bigger. That'll be all right. I mean, presumably, I mean, the ambient temperature in the office is usually like 25, 26 C. Um, oh, you guys can't fully see that. Sorry. My big old head's in the way there. So what do we think? Does this look to be like acceptable? Well, it also asks for temperature rise. It asks for on the DigiKey one says the current, the thickness, the temperature rise, ambient temperature, and the trace length. I don't understand what thickness it's talking about. Unless it's talking about this diameter here. I don't really understand that. Just line these up a bit better. Is there also like there's the auto run, but is there like a auto layout? There, whoa, here we go. It's like 70, yeah. Well, there is a JLC PCB thing right here. Mounting holes. I guess you're right. How would one add in? Do I just do pad, circle, hole? So if we do 1, 2, 3, 4, and slide that over here, down, space. Nope. Can I just draw a new box? What is that? What is that? Height of the trace. Okay. I do like that. I just don't know how to make the actual board. Like, how do I set the border of it? Just do like this. Okay. Like that? Did I not use board outline layer? Okay. I get what you mean. Board outline. I get it now. That. Opening up like this. And then we can do some, this will be the top silk layer. And we can add some text. And we'll call this the X40V2 right. This we're gonna make, well, how do I make that smaller? Groggy, what's up, man? So does that look, when am I coming to Twitch? Never. I don't really want to change to a different platform. The whole diameter, I need this to be, we'll do 3.2 mil for each of these. That way I can use M3 screws without them catching. And then is there a way to like measure in here? Origin. Dual stream. I don't know if my internet can take dual stream. I do not have as good internet as I used to have. So is this like, is this basically done? Is this acceptable? I'm gonna say, what does this JLPCB button do? Does it just bring them up? Two layer. I don't know what, again, like what's the dimensions of this thing? So it's, let's make that 50 by 32. center that a little bit better like this. I can probably make that less as wide. So do 45 wide. No, 47. So that's 47 by 32. Bring this over here. So 47 by 32. And if I wanted to get 10, so export. I just kind of want to see what it would do. Something's not right. With the board outline red is top copper. Oh. So can I change this? This needs to be, let me do that either. That's not right. Should be a purple line. I'll have to check it out, Groggy. I've just never really considered it. Set board outline. So what I oh, right there. Yeah, that looks like that's it there. Still doesn't give me a great thing, but 40, that's 47 by, we'll call it 47 by 32, see what it says there. So I can export this as, so if I look at the JLC thing, it wants a Gerber file. Well, I should see what Instant Quote says without giving it the file. $5. One design, single PCB, PCB thickness. What thickness are we looking for here? 1.6 or 2 mil? Can they be black? How much more expensive is black? Black is doing more expensive. Yes. We're going with the black. White silk screen. Yeah, I don't know what any of this means. Hmm. So, yeah, what's the Gerber file? It's asking for anything. Might have easier. Oh, generate PCB fabrication file. Please save your work. Can you just save for me? Generate that. So what is the design rule? Yes, check that. Ooh, that's what it would look like. That's kind of baller. Black. With lead or lead free? Does it matter? That's pretty cool though. I think it's pretty slick. The one thing I didn't check though is that, so will those terminals actually work? Here's electronics. So a double stack of JSTs. Here. Is good. I want to make sure that a double stack do 2 ounce. Does that change anything in here? Lets me select it in here. Kind of wonder though if I should give myself a little more meat around the those screw holes. Let's save again. Just saved it. The ribbon wires do. The heater wires do. That's this J1 is the heater and thermistor. That's why there's this giant trace going to the 24 volt. Because for that one, there is, let's open twice. There's 3 for the negative side and 2 for the positive side. So I'm wondering if I should beef that up as well. So if I do auto route design rules, we add a negative 24 volt. We do, what's that one called? It's the P1, this one here. That didn't do anything. Because this one right here should have been bigger. Or it probably didn't save. It didn't save, that's why. This one here, apply, settings, run. There we go. So now that's bigger. Okay. So that now comes down to the, so that's, okay, so that means going back into here and specifying the connector. So, um, what is that connector called, Aaron? I need the name of some type of screw terminal. What does Amazon have? Yeah, so crikey. Yeah, because there's like this kit here. What are these rated for? 150 volts, 300 volts, 250 volts, and then 6, 8, and 10 amps. So any of these would do. But it's just like this. I need to identify the spacing of them so that the PCB can be proper. And it's not only SIMARC, it's not only about finding the part number, it's also sourcing the actual part. Because I don't know if I have anything like that here. I mean, I could steal some. I've got some on, I have some external MOSFET boards that these would probably do the trick. They look like they're just these little blue ones right here. And these are good for 10 amps. Yeah, these are plenty. Well, okay, they can set it with the board, Aaron, but there. Is that gonna come up? Go to site. Okay, so Aaron sent me this. So this is I've only ever searched DigiKey for fans. I've never searched DigiKey for anything else. Oh, it's Chinesium. Well, the 3-pin can do. Well, that's 2, 3, and 3. This is a 3-pin. Looks like 17 amps on this guy here. So if I copy that, this guy right here. So if we call this, so where's my flaggy tool? I add here to here. If I call this P1 dash 24 negative, I called this plus 24, I can delete these two flags. And that will break out those two, right? That should do it right there. So if I do update PCB, keep going, go here. That didn't change any of this. So let's go back to here. Let's save, design, convert schematic to PCB. Why didn't update this one? It was minimum of 5. We're getting there, Andre. We're getting there. I just update PCB. Yeah, those are all good. Apply changes. Okay, so now I have to put screw terminals like right here. Then route, auto route, run. And it would look like that. So that would be with J1 would only have And one of the blue ones is 1,000. Where does it say? It doesn't say that in here. Data sheet. It says 5. You can do 5 of these ones right here. Sales price per piece, a full bag is 1,000. They're 9 cents a piece. Minimum 5, multiples of 5. Yeah. It says right here, minimum 5, multiples of 5. Yeah, and even on here it says minimum 5. Yeah. So this is the new layout. 2 layers. So it's, I think there's any other terminals that we need to change out. If I put it on the other side, I guess it could. Like that. I think that's better. This is going to be hot end, or we call this heater. And then I guess if I do a negative there, positive there, I'll do a negative on that side, positive on that side. That way, you know which side is positive, which side is negative, which really shouldn't matter, but it's fine to annotate it. Because heaters don't, this link right here gets severed, but yeah, because otherwise it would screw up other things. So I'm just going to keep it like that. I kind of want to add a, so no, that's just the positive and the negative. It's an excellent question, Aaron. I don't know. That's 1.98 millimeter. So the box says 2.54. Vince, how you doing, man? Yeah, 2.5. So these say 2.54. Um, these are only 1.98 center to center. So I'm guessing I need to, JST XH. Is that what these are here? It says adapter and connector set. Doesn't really say anything. I don't see those anywhere here. I don't know what any of that means. Mine do not. But I mean, and again, I can have those included, right? I'm just a little worried that it won't actually fit standard JST connectors. So you said it's B, 3B dash. Does that pull up anything? Yeah, okay. So this, that's a regular old 3-pin? Okay, so I need a 4-pin and a 2-pin. And they've got 3-pin. Okay, Aaron, I'll try that. C95. Okay. Can I like replace these then? Can I find similar objects? No. So I'm gonna throw one of those from Aaron there, so I can remember that one. And then oh, the B4B is the one that Aaron found there. Now, what's the 2-pin version of that? A B2B? An A? Okay. Yeah, so here's like I really don't want to have to redo all of these pins now. Because I think it's going to be that where I have to relabel all of these then. Change a component type existing connection. I don't see that anywhere because when I right click it, I can edit the symbol. Okay, let's try that with this. So we'll call this X2. Does that work? Does that like, if I do that? Call this E1. E1 exists. So delete this. J1. Let's just do a quick save and then update PCB. That does work. Okay, cool. Cool. So now R1. X. 1. And 2. And then save. Update PCB. Okay, now I gotta just doing it to see what happens here. Yeah, some of them are, yeah, that's fine. Pin 2 and 3 and 4 here isn't. Oh, I need to change it in here. The hot end. And then that's supposed to, what's that supposed to be? So that's the X ones. So that's supposed to be X2. Good catch on that. So I can save this then. Design, update PCB. Like that. These connectors are a bit bigger. So I might need to make the PCB a little bit wider here. I always put the X max on the end here and give things a little bit more space. kind of do like this here, I guess. Route, all that jazz, run. Like that. So it's just a ribbon, just a ribbon one. Okay, well, we can make this a little bit bigger then. Drag this down. This guy down here. Actually, I'm gonna pull these out more. This guy down here. Pull these ones all down. That's some more space. Like that. Everything. Does that look better? You can take a look at 3D view. 3D view. Ew, this is cool. Oh man. How baller is that? Now, is there any way to like actually space these? This is so freaking cool. Um, like to like properly space them, because like clearly this needs to go over here a little bit. This needs to come middle here. It's centered there. Can the IDC connector be inserted to see if you have enough room? I don't know what that connector is. So this is just so if I go, I guess I can go back into here now. So if I do a 2 by 13, so it's a pinned, let me get the cable. Yeah, here it is. So this is the connector here. It's got the one registration point on it. Aaron, give me a part number. Let's see what Aaron says. C273241. So place that. Okay, so need to delete that. Pop that in there. And then let's look at 3D view. Oh my goodness, this is so freaking cool. Yes, I need to change this to say right. That looks pretty good. I should have enough space. What do you think? Does that look all right? Some of the nets don't look fine. I mean, everything's connected here. Yeah, I mean they're all connected here. You can see all the names are on all the pins. And then 14, 15, and 16 aren't used on the right side. But when I do the left side one, which definitely won't be tonight because it is now after 1 a.m., when I go to do the left side, it does use these 3 extra pins for the probe, which is this schematic here. So in this one, there's another 3 pin. So everything else is the same, except this extra 3 pin gets added. So what I'm going to do is I can just copy this layout, put it into a new one, and add this 3rd connector and call it a day. Can I zoom in? What do you want me to zoom in on? Here? I will wait here until you reply back. On my drink. The blue terminates at the 3 reds. No, that's just it going from top layer to bottom layer. There's a couple of them that do that. So like this connection here is on the bottom layer to all 3 of these pins, and then the top layer connects these 2 together, then all 3 of those pins connect here and go out to the positive. So the blue is just bottom layer, and then the red is top layer, but some of these go like, so this one right here. So this E1M2 goes from a bottom layer trace here me see, bottom layer here, then it comes up to the top and then goes around to where it needs to go to. Does that make sense? Yeah, see, so with this, these two pins are connected, and then these two are connected, and then they all go out on this pin here. These three pins connect to this one pin and go out. Hey Adam, how you doing? Well, Wolfgang, how you doing? Saw you come in there. Adam, designing a PCB for the WeDo. Because why not? And look at it in 3D view. It looks amazing. Oh, looks so cool. Ah, Andre, okay. Yeah, yeah. This one is color coding, whether it's a top layer or bottom layer. I don't know how to fix this. Yeah, so the WeDo has those ribbon cables, and I am still on the. Yeah, I know that notch is there, and I don't know how to get rid of it. I think I have to just delete the whole thing, and then uh, shoot, where is that at? Set board outline. Just take that up a little bit, out a little bit here, down a little bit here, like that. Go back to the 3D view. And there it is. Yeah, and you can even see right here where it pops up from the bottom. Right there. This is so freaking slick. I did not know you could do stuff like this, like on a free program. That's the thing. Like, I mean, they're tied in with JLC PCB, but like, it's such a cool thing. Oh man. Well, I think that's gonna be it for tonight. Now, doing the again left side will take 2 minutes to do, um, because all I have to do is add one more connector. And that'll be it. Although I think actually I can make this one PCB and then you just not solder on that other connector. You know what I mean? So like here on the right, if I move this up and I add a 3-pin right here connected to those, then you can use it whichever one you want. I can export it as an OBJ. Yeah, JLC emailed me 2 months ago, 3 months ago maybe, like twice within a week, saying, "Hey, if you've got a project, let us know. We'd be happy to work with you." So, and I was like, "Well, that's cool. Like, I see a lot of people do cool things with JLC PCB, but I was like, I don't really know anything about PCBs." And then I got the X40, and then I got on the idea of reusing the ribbon cables and do a conversion to a better board with better firmware. And this kind of just dropped in my lap to be able to do this. So maybe they'll say yes. I mean, they emailed me like a couple months ago. Someone replied to a pretty old email to say, "Hey, this is what I think I want to do. Can you hook me up with a couple of these?" And then, like I said, I think I'll give some away. Um, if they can give me like 5 of each, then I can do, giveaway to 4 other people. I've never gone to them either. And again, I've just seen, um, I mean, because it also made me think about it because Stefan just did a sponsorship with JLC. Um, he made a, is that better? Yeah. He just made a PCB with them as well. So, I got a couple minutes here. So let's do um, library. Let's do B3B. And then we need A. Yeah, we need this. So I need this one here to rotate it like that. And let's pull up that one. So that's just called Hall. Okay, and then let's just do that. Oh, that's the right side. Where's the left side at? So pin 1 is S2. Pin 2 is ground. And this one is S24. I can run these ones separate. So I'm going to call this um, Hall plus 24 and Hall ground. And then put 15, 14, and 16. So 16 is the Hall plus 24. 24. 14 is the Hall ground. Or no, 15 is Hall ground. And 16 is Hall S2. Like that. So then if we save, I go design, update PCB, apply, and then something's not connected. all dash S2, oh, right here, all dash S2. There we go. Now we can do update PCB. Now it's connected. Okay, now we can do the route, auto route, run. Okay, and there we go. So now this board can be used for the left side or right side. Swap the 3-pin with a fan header for more fit. Oh, over there you mean. Okay. So if I pull fan 1 over here, it's here. That's crooked. Like that. Now we can do route, auto route. And then let's look at the 3D view again. No, that's fine. Just think I want to. This needs to be this way to be like all the other cables, connectors. Ah, it's crooked. Oh, how do I turn that one? Oh, like that. Okay. Now if we run the auto route again, and then check out 3D view. Oh, hang on, I'm not done yet. So this isn't, I'm gonna call that ribbon just because fabrication export a Gerbil file. So fabrication, PC fabrication, save it. Generate the Gerber. Yeah, so here it is right here. Gerber view. Oh, that doesn't work. Okay. And then, yeah, so it looks like that's it. Oh, crap, it's getting late. It's a good thing I have off tomorrow. So what do you think? Do we think that looks good? I think it's a pretty bang up job, if I do say so myself. I also want to go find that email. Oh. Oh no, it wasn't JLC. It was PCB Way that emailed me. Well, I mean, I can also email JLC and say, hey. Oh, Adam, this printer doesn't have a transformer name. At least not yet. If it gets Clipper, it will. Or I guess if it gets RepRap, I'll get the transformer name eventually. If anything, I would add my logo to this, but I think it's okay with just name one there. Oh. All right, well, I'm going tonight, guys. It's super late here. I'm exhausted. Um, so yeah, thank you everybody for your help. This is like awesome. You guys were able to help me out with this. Super duper geeky stream. We had very few people watch, but those of you that did helped out. So, um, yeah, it's been fantastic. So, thank you everybody for hanging out, and I'll probably stream again sometime in the near future. I don't know if I'll do anything before Christmas, but after Christmas, probably. So, y'all have a good night, good rest of your day, and I'll catch y'all next time.